So hello, we are from Group 2, Section 4, Chemical Engineering Thermodynamics project. So our topic is flash calculation to separate mixture between methanol and water. So this is our group member, Muhammad Idam, Muhammad Arif, Chairperson, and Nurul Adelina. So our slide contains of our objective, process conditions, flash column, free body diagram, and flash calculation. So our objective for this project is to separate the mixture, which is benzene and water. So the second one is to calculate moles of liquid, moles of vapor, and liquid phase mole fraction and vapor phase mole fraction. Lastly, plot the graph of TXY and PXY graph.
Okay, so next we go to the process condition. Okay, as you can see here, there are property assumption. So the first one is we choose system behavior. We choose ideal solution, which is law apply. We assume the mixture behave ideally and ignore non-ideal effect like hydrogen bonding. While methanol water mixture can deviate from ideally, this assumption is reasonable for the first approximation in education project. So the second one is the pressure. We choose 70 kilopascal to ensure the partial evaporation at 75 Celsius. This pressure lies between the bubble, which is 94.3 kilopascal, and dew pressure 61.4 kilopascal. So confirming a two-phase region exists, subatomic atmospheric pressure also lower energy cost compared to higher pressure system. So the third one, the fat composition. So we choose 50 mole percent of methanol and 50 mole of water. So this to avoid the azeotropic composition where separation becomes challenges. This balanced composition clearly demonstrate vapor liquid equilibrium trend. So the fourth one is fat condition. We choose a saturated liquid. So the fat enter as a saturated liquid to ensure immediate evaporation when the pressure drop in the flash drum. So this will avoid unnecessary preheating or compilation from two-phase fat stream. So the last one is temperature. We assume 75 Celsius. So at 75 Celsius, methanol, which is boiling point at 64.7 Celsius, readily vaporize, while water boiling point at 100 Celsius mostly remain liquid. So this temperature optimize selectivity for methanol recovery. Next, we go to the flash column FBD. As you can see here, the fat enter the flash column at 100 mole per hour of mixture. So the basis here is 100 mole per hour of mixture is fed into the flash column. And the pressure of the inlet pressure and the inlet of the temperature is 70 kilopascal and 75 Celsius as a saturated liquid. So the outlet here, we got two outlet stream, which is vapor phase at the top of it and the liquid phase at the bottom of it. So as you can see here, the composition of vapor stream and liquid stream will be obtained later. So the further calculation will explained by Arif and also Chad.
So for the part calculation, first we need to find P set. So for the find P set, we need to use Antoine equation. So this is the formula for Antoine equation, and this data that we need to use for Antoine equation. This data we got from Appendix B, Table B.2. So this is calculation for P set methanol and P set water. P set methanol we got 149 kPa, and P set water we got 38 kPa. Next, we need to find P bubble and P dew to make sure our pressure is between P dew and P bubble. So, to find P bubble, we use formula X P1 set plus X2 P2 set. X is the mole fraction for liquid. For the calculation for P dew, we use formula 1 over Y1 over P1 set plus Y2 over P2 set. Y is a mole fraction for vapor. So we got P dew equal to 61 kilopascal. Since our pressure between P dew and P bubble the system is in two-phase region so that the flash calculation is possible.
So next is the PXY diagram, which shows the pressure composition at 75 degrees Celsius. So the blue curve is the bubble point, represent the liquid phase composition, and the dew point, which is the red curve, represent the vapor phase composition. So at given point, at P is equal to 70 kPa, which is the operating pressure, the tie line shows that the equilibrium composition of the liquid and the vapor phase.
Next, for part calculation K1 and K2 from Rod's law, equation 13.16, we have K equal to Y over X equal to P set over P. So from that, we got K1 for methanol is 2 and K2 for water is 0.552.
Okay, so today I'll be presenting about the flash calculation. So by using the Roots law to find the liquid mole fraction, we know that value of x1 plus x2 equal to 1. So by modifying the equation, we can know that x2 is equal to 1 minus x1. So we are using the Roots law equation. The total pressure is equal to the mole fraction of liquid 1 multiple with the P saturation of liquid 1 and plus the 1 minus x1, which is also the x2, which is represent the liquid 2, which is water. So liquid 1 is methanol, then multiply with the P set of the water. So by substituting all the value, then we can have the value of x1 and x2. So x1 is equal to 0.2820 and x2 is equal to 0.71 m. So for the vapor mole fraction, so we know that the formula is y1 is equal to x1 multiply with the P set and divide by the total pressure, which is 70, our operating pressure. So we can have the value of y1, which is 0.640. So y2 just minus with y1, 1 minus y1, so we can have the value which is 0.3960 mole to mole. So the liquid phase and vapor phase mole. So total balance, we know that our basis is 100. So liquid plus vapor must be equal to 100. So by using the methanol balance and using the water balance, by substituting it into the calculator and for simultaneous equation, we can have the value of liquid phase and vapor phase, which is 32.30 for liquid phase and 67.70 for mole phase. So that's all from me. Thank you.
The next one is the XY diagram, which is for the methanol water system at 70 kPa. The blue curve is the bubble point curve, which where the liquid start to vaporize, and the red curve is the dew point, which where the vapors start to condense. So the green dashed line is the tie line at 75 degrees Celsius, which connect between two curves. So this system is in two-phase region. The tie line shows the equilibrium composition of the vapor and the liquid at 70 kPa. So for the conclusion, the flash distillation successfully separates the methanol and water into liquid and vapor phase. The TXY diagram and the PXY diagram confirms that the system operates in two-phase region, which is at 70 kPa and 75 degrees Celsius. So we applied Rod's law and Antoine equation to determine the bubble point and the dew point. Equilibrium composition of liquid and vapor phase were determined by using the tie line that we have been plotted on the both of the graph. That's all from us. Thank you.